Hello and welcome back. My name is Alex from Nourish, Chicago, and today we are going to be making popping boba. Before we get started, in this recipe you will need a bag of sodium alginate, distilled water, a bag of calcium lactate, and a flavoring liquid of choice. If you watched our previous video about molecular gastronomy and making milky spheres, you will realize the process is very similar, except this time you can use any liquid flavoring of your choosing. The first step for preparing popping boba is to measure out 500 milliliters of your flavoring of choice. You want to blend this with 2 grams of sodium alginate. Let this solution rest for 2 to 3 hours or until all bubbles are gone. I pre-made the solution, which you can see here. You will then want to prepare the calcium lactate solution. You can also use calcium chloride if you have it. Be sure to be careful when making this solution, as it is exothermic, meaning it releases a lot of heat and can get very hot. Measure out about 2.5 grams of calcium lactate and blend it with 500 milliliters of water. Once the calcium lactate solution is prepared, you can take a syringe or spoon and place small drops of your prepared flavored liquid into a bath for 1 to 3 minutes. The popping properties of each boba depend on the amount of time you keep it in solution. Try leaving the boba balls in at varying time intervals to see what I'm talking about at home. Once time has passed, make sure to wash your popping boba several times before eating. Delicious. Now that you've seen both direct and reverse spherification, you might be wondering what's the difference. The difference is what's in the bowl. For direct spherification, the bowl contains calcium lactate, and for reverse, it contains sodium alginate. Switching the placement of the bowl and dropper solutions affect the thickness of the membrane. Direct spherification produces a thinner membrane that pops when you bite into it. Reverse spherification creates a thicker and more sturdy membrane. The science behind the formation of the membrane remains the same. Sodium alginate is a polysaccharide derived from seaweed. A polysaccharide is a chain of sugars. Alginate contains multiple negatively charged groups, which bind with sodium's positive charge to make the salt. When you submerge the sodium alginate in the food liquid, the sodium and alginate separate. This is when we add drops of it to our calcium lactate bath. Calcium has a +2 charge while sodium has a +1 charge. The charges are like hands, with the +2 charge on the calcium being able to grab 2 molecules of alginate instead of 1, causing them to tangle more. This leads to the formation of a membrane of alginate on the outer surface of the sphere. Thank you for joining us today. Now that you have seen me do it, follow along with your Nourish Chicago volunteer. Thank you for watching.